Welcome! We're at the Hiller Aviation Museum in San Carlos, California, and this is our training tutorial for the NASA Four-to-Soar Aerodynamics Lab program and the Traveling Flight Science Lab Traveling Flight Simulation activities. We're going to take an opportunity to look at each of several different hands-on programs that are offered as part of these two programs. Additional resources to assist you in implementing them at your museum, science center, or classroom setting can be found on our website, which is www.hiller.org. Navigate to our education page, and from there, go on to teacher resources. For now, let's get started by looking at some of the amazing activities that will bring aviation to life for your students. We're at the Hiller Aviation Museum's Aviation Adventure Center. Here, we have 12 different flight simulators, identical to those used in the Traveling Flight Science Lab program. Each will allow us to accommodate up to 2 different people for programs oriented towards the general public, school groups, scout groups, and others. We're going to use one to take a look at how the different features of the flight simulators can be used to enhance the experience for visitors at your museum. Here's a typical flight simulator installation. We're currently running Flight Simulator 2004, which is preferred for basic education programs. It's less of a chance of skipping or crashing in between flights. Crashing in this case referring to the computers, not to the kids. When we orient our visitors for the first time as a group to the flight sim zone, we make sure that they're aware that one pilot flies at a time. We have them work in pairs. One pilot observes, one pilot flies. Correct position as with an actual airplane. They'll put their feet on the floor, heels on the floor on the rudder pedals, left hand only on the yoke, right hand only on the black control, which is for the throttle. We explain each of these for the kids. Our orientation continues with a review of simulator controls. There is a keyboard, not shown here, on which only the letter P is needed by our visitors. Visitors press P to begin each mission and press P again at the end to allow the instructor or volunteer leading the activity to change to the next simulation. On the yoke, there are 2 controls of note. Students in particular will notice the red button. It does not allow them to open fire on objects below, but instead will change their view. So we'll be outside in control tower view. Another press brings us to outside of the cockpit view. Yet another brings us to a zoomed up cockpit view. We prefer this view. So if by chance the view accidentally changes or is forwarded by the software automatically, visitors should press the red button repeatedly to return to this view. On the top of the left side, we have a top hat controller that allows the view to change. So we're looking out the left window, looking out the right window, or if we're so inclined, we can be owls and look all the way around. However, our standard view is straight ahead, looking over our standard instruments. In this case, the instruments in our Cessna 172 that we'll use for straight and level, our very first tutorial. Now, before we bring our visitors into the flight simulators, we want to make sure our settings are properly set for the activity that we have planned. With the general public, we usually put crashing on and set our realism settings up to discourage folks from flying excessively beyond the edges of the envelope. With school and scout groups, however, we don't want to discourage them by making it too easy to crash the airplane. So we'll change our realism settings. We'll hit the ALT key to bring our toolbar up. Again, this is in Flight Simulator 2004 or Flight Simulator 9. We'll go and select Aircraft. And from Aircraft, we'll pull up Realism settings, and this will give us our realism settings screen. For education programs, we will select Ignore Crashes and Damage. We will select Easy Flight Modeling for all different factors, and for basic flight, we will select Auto Rudder. For flights involving crosswind landing, we'll disconnect the auto rudder so that the visitors can practice crosswind landings. Once everything has been selected, we say OK, and we're ready to fly our simulation. The basic scenario is straight and level flight. We use a flight over Foster City near the western end of the San Mateo Bridge. For each stop on a Traveling Flight Simulator Labs tour, different straight and level flights are programmed appropriate for each host institution. The basic goal of flight simulation with straight and level flight is simply to introduce the visitor to how the simulator works. Again, the simulation begins paused. We press P and the airplane is flying. We can demonstrate how the airplane rolls left and right. we demonstrate how the airplane pitches up and down. We demonstrate, especially when the auto rudders are off, how the rudder can allow the airplane's nose to yaw left and right. We also demonstrate that bringing the airplane straight up does not allow it to climb, but instead creates a stall as the airplane loses airspeed and the wing ceases to generate lift. Furthermore, we'll show our visitors how pitching forward is not the best way to descend because it will create an excessive airspeed that might damage our airplane. Instead, we'll introduce the use of the throttle. Straight and level scenarios use the Cessna 172. There is no variable pitch propeller on this airplane, so the blue control for propeller pitch has no effect. The red control will remind everybody that in an airplane, anything that's red is red for a reason. It's red to remind us, think before we touch it. In our flights, we have no need to touch the mixture control. We do not wish to shut off our fuel in flight. However, we are going to use our throttle. Full power allows us to climb. Reduced power allows us to descend. In straight and level flight, we allow our visitors to fly around. We give them perhaps 3 to 5 minutes to explore, then we'll ask them to switch. To facilitate switching and make sure everyone gets a fair shake, when we switch with 2 students or 2 scouts at the same simulator, we'll use the control semicolon command, which immediately restores the simulation to the beginning of the current flight. This particular flight has been selected as straight and level. Once the students have had a crack at straight and level flight, we move to the next and more challenging flight simulation, which is final approach. The next flight is final approach. Final approach gives our visitors an opportunity to attempt to land the Cessna 172. For our purposes, we give them a very forgiving airport. San Francisco International. 2 parallel 2-mile-long runways provide ample space for landing the Cessna, but the presence of the bay makes it a little bit challenging. For each stop on a traveling flight simulator lab, an appropriate home airport is selected for final approach. In each case, the airplane is configured on final approach, 1 notch of flaps at an altitude of approximately 800 feet above ground level. In this case, we're going to instruct our visitors to attempt to land by maintaining a constant airspeed and a constant glide slope. I like to tell my groups that we're going to maintain glide slope by pitching until the top of the control tower is about 1 inch below the end of the runway that we're attempting to land on. And we're going to use our throttle to maintain our approach airspeed. For our purposes, we choose 70 knots. 60 knots is an equally appropriate airspeed for the Cessna, but for our purposes, rotating multiple groups through with multiple landings each goes a little bit faster with a higher approach speed, and that's also a little bit more forgiving. Let's see how it works with the 70 knot approach speed. We begin by pressing P. We pitch down to achieve our 1 inch glide slope. Our airspeed is high, so we will reduce power to decelerate. We're going to select one runway for our landing. We're going to land on the left runway here, maintaining 1 inch, maintaining 70 knots. Our visitors frequently will lose sight of the runway altogether. They will frequently pitch too high. It's also very common for them to allow their airspeed to escalate. Airspeeds of 80+ knots are quite common with both students and members of the general public. We remind them by circulating between the simulators that we want to maintain 70 knots and we wish to maintain 1 inch visual glide slope, the separation between the top of the instrument panel and the bottom edge, closest edge of the runway on which we're attempting to land. We're about 1 mile now on final approach. Our altitude is 400 feet. We will continue flying 1 inch, 70 knots, all the way down to the runway. As we approach, we'll make sure our visitors know that we wish to land on the back wheel. So we'll need to make 2 changes as we approach the runway. First, we'll need to pull our power all the way back to idle. It's very common for our visitors to attempt to land with the power still up. It doesn't work very well. So when we get there, we're going to pull the power all the way back and we're going to gently pull the nose forward so that we land on the stronger back wheels first. As we approach San Francisco Airport, throttle is now all the way back. The nose is up. We're going to hold a level attitude as the airplane slows and settles onto the runway. Back wheels strike the ground first. Nose wheel now strikes the ground. We will use our foot pedals to steer. And we'll use our toe brakes by pressing on the tops of the pedals to bring the airplane to a full and complete stop. We use final approach in a scenario where each pilot flies twice. With a pair of pilots on each simulator, one pilot will make an approach, we will switch pilots, the second pilot will make his or her first landing, and then we'll do it again, switching pilots each time so that each pilot has 2 attempts to make a successful landing at the airport designated for final approach.